Le récepteur.
Bonjour à tous et toutes. Je suis ravie de vous avoir ici aujourd'hui pour la présentation des projets de fin d'année de C20 en spécialisation. Ça fait 18 mois que vous êtes chez nous, 18 mois que vous avez beaucoup de curiosité, de persévérance dans votre apprentissage. Donc aujourd'hui sur le campus de Lille, on est ravis d'accueillir 4 étudiants qui vont vous présenter leur projet de fin d'année et également des professionnels que je vous remercie d'être ici. La parole est à vous. Bon courage. Bon déroulé.
Hello everyone, thank you for joining us for our presentation of our portfolio project. Today we are going to talk about a web application at the
So for our team, I'm Jérôme Bernard, I'm a C20 in the C20 course and I'm the full stack developer of this web application.
I'm Kevin, C20 from Lille. I work on the full stack of the web apps.
So for the story of the project, how everything started when my family decided to opening the bowling salon. I wanted to contribute by creating a web application to simplify their processing. So I took on the challenge of developing a first prototype to enrich my portfolio. The advantage of this project is that I meet a real demand which significantly increased the chance I will continue the project after Roberton. To successfully carry out this project, I reached out to the best. He agreed to join me on this adventure, Kevin.
Thank you, Jérôme. I have integrated into the project the ability to export appointment for any service, so that the web apps features are adaptable to types of requests. I have also ensured that the web application is simple, easy to use, and accessible to everyone.
So, the demonstration of our project.
So, Jérôme, would you like to comment?
Yes, I comment this. So, this is the main page of the application. You can see all the header with the main part. All the tips you can use on this application with the booking and the weight. On the back, you have how you can do the book now, it was the step, and on the bottom, the whole link and all you need to access to your profile. For the first page, so the service, you have all the list on the service you can take in this web application. On the next, you have the store with little tools you can buy if you want. In the third page, you have all the contact with the mail, number, phone, etc. And for the last, you have the book note.
Thank you, Jérôme. We will start by logging into the dashboard.
Yes. So we register with the admin account. We log, and you have all the name and profile you have on this application form. In the book note, you have all the appointment list with the history. For now, we don't have appointment list, and you have all the service on the store you see in the previous page. So, okay, can you create a new service, please?
Yes. Sorry,
thank you. Thank you, Kelly, for me. A little description, for example, and a price. How many? For me? It's not very much. So, we can submit, it's successfully added, and it's now present in your service. No store, Kelly?
Yes.
Okay, the new item?
Yes. So we are.
Thank you for making too. A little description. And for this price? Thank you.
I don't know
If you don't have a right, it's not a problem, you have a default image. So it's to validate.
Yes. The service of store quite here will be added gently to the respective page, service, and the store page.
Yes.
Okay, are you disconnected? I create a new account.
No, we can create a new account. So you go to the sync app and you create your name, email, and password. So the register is due. You have no code sent to your mail. You already start this before to ready. So you can copy paste the code and send it on the case. And you are not connected with a new profile. So again, I want to take a book note.
Yes.
So you have the fourth step with all of the previous servers in the first. You can select one or two if you want. If you want all, you can select on the bottom the after last page. Yes, can you select it, Kevin? So all the previous service has added, but if you want nothing, you can click in check in for cancels. And all the services are deleted. So now for the timeline. When did you want to go?
Tomorrow.
Tomorrow for hour 14? Okay. So we can confirm it.
This is page if you can use some personal information, name or email, verify if that are correct or you can change your profile.
Okay, and for the next, you have all the summary of what you do, and you can submit it, and you also write the last mail to confirm all the information. So in the previous page, new mail is sent, and you have all the description of what you check. Now, Kevin can return to the previous admin accounts. We go to the account list to see if the book is read in this. You also look and you have the account list with the. Thank you, Kevin. We can return to the project. Our project, thank you, Kevin, is about the architecture. We build this project in three main parts: the front end, back end, and database.
Front end using user part, we use Vue.js to build the application interface, providing a smooth and dynamic user experience. The navigation system is managed by Vue router and the call to backend server service and with action. Backend server side part, the backend is developed with Node.js and Express. It handles the business logic, user request, and the data security using JWT for authentication for required for encryption. Database, the data is stored in a database managed by Spécialisation with ORM. This makes it easier to manage data and interaction with the database, such as querying and retouching users.
This architecture demonstrates how the application is structured to be robust, secure, and scalable. For next security.
Let's for a moment to talk about security. There would be too much to say. Let's discuss some points that I find important.
So to secure our backend application, we have to implement a simple yet effective measure. In first, we use a bcrypt to encrypt password, making them unreadable, even if the event of the database are rich. Session cookies are secure to prevent easy access and their leaf spawn is limited. The course, protection realistic access to the application to only authorize advanced such as localhost form. We ensure security with Helmet, which protect against attacks like clickjacking and malicious scripts. Sensitive information such as database credential is stored securely, and finally, regular security tests are conducted to anticipate new threats. In summary, this practice ensures the ongoing security of our application.
All this is to protect what matters most.
Our users.
This is image we see JavaScript, so the snippet that handles authentication using JWT. This code contains three essential functions for managing token.
So, for the three functions, you get the get user right in the first. This function expects and validates the GWT token from the authorization headers and check the token's validity using a secret key. If everything is valid, we return the user ID. In the second part, we have the generate temporary token. So, like the name says, this function generates a temporary token validate for 15 minutes by seeing the user ID with a different secret key dedicated to temporary token. And the last function, we have the past temporary token. Like the name says, this function cleans up the temporary token by removing the buried prefix, making the token usable.
These functions are typical in security in application with GWT token, used to ensure that online authentication requests can access, protect the resource.
For the timeline,
First week, set up the database configuration, create the development environment, and define API route. Second week, the test API using Postman, implement login registration and user management, create a token generator, and start the front-end development.
For the third week, we develop the API function for full calendar and connect the backend with the frontend. And for the last week, we focus on the debugging and testing under system.
Not forgetting the front-end in between. This is how we dividing the tasks so that we could both try a bit of everything.
As for the challenge uncovering during this project,
The discovery of a new technology, Vue.js, managing the contingency for communication in group, the competence in front and back for the interactivity and communication in there, and finally the environment variable to allow the cohesion of the project of any major.
For the non-technical aspect, we find the stress under pressure. When one feature has problem and you have to go to the next, it's never pleasant. It always requires a lot of work, especially short of time. Motivation can suffer, but being in the team compensates for this challenge.
We plan to import the visual appearance as well as each feature such as.
In the first improve, we can enable detailed tracking of user appointment, adding a payment method to the apps when the user takes a book note, and finally, alert an appointment confirmation for the manager.
Finally, it was a very interesting project, and we learned a lot. The tools we used were perfectly suited to our project, and we didn't have any problem with anything. We went so quickly that we didn't even notice the time passing. No sooner had we finished the project that it was already time for the presentation.
Our presentation is now over. Thank you all for listening to us.
Do you have any questions?
Someone have a question?
Why did you use a MySQL database?
Why did you use a SQL database? So we use SQL because it is ORM when we can use MySQL in there, and it's necessary to the RNCP project.
No, why did you use a SQL database?
SQL.
SQL database. Not, for example, MongoDB or.
It's the same response. We need to use MySQL for the NCP project, and we want to try it in this project.
C'est une question?
Maybe. Which kind of frameworks are you using for the backend? the frameworks.
We don't use the frameworks for buckets. C'est pas une autre framework. It's ORM.
No, for Node.js. Are you using some framework
For
for?
backend, yes, Node.js. Yes.
Yes, so it's just Express from scratch, or maybe another framework.
Just Express with Node.js and not another framework for now.
Okay. You don't use TypeScript, so.
Not this project.
Yes. How did you test your app? Did you do beta testing with some users? Did you do unit tests?
Pour les tests, on a utilisé OWASP. OWASP.
Web data.
Pour les tests. C'est les seules choses qu'on utilise. On n'a pas utilisé de J-test. On a utilisé que OWASP et on a eu des retours assez intéressants sur la sécurité.
Yes.
En français, du coup.
Yes.
Vous utilisez quoi comme builder pour le front-end? Parce que ça, c'est Vuex, le
Oui,
c'est ça.
Et du coup, c'est quoi? C'est du Webpack, du Vite, du...
C'est un framework de UX, c'est un framework qui est...
Non, Vuex, c'est pour le storage.
Oui.
Mais pour builder la solution, en fait, c'est du Webpack, c'est par défaut, c'est du Vite.
J'ai pas compris.
J'ai un peu de mal aussi à comprendre la question par rapport au back.
En
On a
fait,
créé nos dossiers front et back, et derrière, on s'est assuré de faire le front en
Ouais.
JS.
mais vu, il doit bien être compilé. Ouais.
Pour l'exportation. Pour
Ouais.
après, ici, non, on n'a pas encore passé à cette étape-ci pour l'instant.
Merci.
Merci.
C'est du TypeScript qu'on compile.
Pas d'autres questions? Ok, on revient dans 12 minutes pour la prochaine présentation.
Thank you.
On est de retour sur le live, cette fois-ci pour la présentation de Thomas, en spécialisation à RVR, qui va nous présenter son projet. Bon démodé.
So, hello everyone. So my name is Thomas, and today we'll talk about my portfolio project, a 3D game engine called Molly. So who am I? My name is Thomas. I've been making games now for several years with multiple engines. I'm also into low-level game engine and graphics programming, as you will see with this presentation. And on the screen you can see a little selection of my games that you can play on my website. So before talking about my project, I just wanted to answer the question, what is a game engine? So maybe you know Unity and Unreal Engine, so they are the two most famous ones. Basically, they're just full softwares with a UI, with a lot of functionalities, a lot of tools that allow you to make games. But you can make not just games with them. For example, with Unity, you can make mobile apps. For Unreal, you can make the VFX for the movies. So at its core, a game engine is just a software that takes data in input and draws something on the screen, and it is used to make real-time rendered interactive applications, not just games. Another particularity of a game engine, it has a really huge and complex architecture. So as you can see on the picture on the right, this is an example of a complete game engine. And as you can see, there's a lot of components that has to work together. So it deals with a lot of data and a lot of calculations. And the software has to be really fast because you only have 33 milliseconds to draw an image on the screen to stay above 30 FPS. So what are my goals with this project? So the first one is to learn more about C++. It's quite the standard in the game industry, so I wanted to learn more about it. My next goal was to make an engine from scratch to learn more about game engine architecture. So all the engines, they don't share the same architecture, but they share a lot of key concepts. So by making an engine yourself, you learn a lot about just how the other engines work. And finally, for this project, I had to reduce the scope. My goal was to make the renderer. So it's the most important part of a game engine because it's the one that is responsible for drawing things on the screen. So I present you Molly. For the programming language, I use C++. For the graphics API, I chose OpenGL, so I will talk about OpenGL later. And for the build system, I chose CMake. And my main goal for this project was to be able to render a small 3D scene and move around. So this is the timeline of the project. As you can see, the first week was mostly planning and the project setup. From week 2 to week 6, it was just adding all the features I wanted. And for week 7, optimization, debugging, and documentation. So this is the architecture of my engine. So as you can see at the top, you have a core library that will be built as a DLL. And basically, it's just the library in which you will find all the code that is used by the applications that use the engine. So it will do all the process that is done under the hood in a game engine. So for example, window management, input handling, rendering system, and stuff. And below the core, you have the apps. So the apps, you can have as much apps as you want that will be built as executables. And they will just contain the game specifics data. For example, the scenes data, so where are the objects in the scenes, the resources, so the 3D models, the scripts, the audio, etc. And in the apps, you will just do calls to the core functions to draw your game on the screen. The pros of this architecture is that it makes the engine extensible and reusable, so you can make as much apps as you want. And it has a high abstraction level to make the engine easier to use. But the major cons of this architecture is that if you don't dive into the core code, you won't have much control. So now I'll just do a quick demo to show you how the architecture works in reality. So this is all the files you will get if you clone the repo on GitHub. Here you have a directory containing the core library, and you have different directories in which you will contain the files of the apps. So if you want to create a new app, you can just launch this Windows batch file, enter a name for your project, and it will create all the files that you need to make a Molly application. So there's a resources folder in which you will put every 3D models and stuff. And there's a source folder in which you have one CPP file. And if I open it in Visual Studio, so this is how it looks. So this is just 50 lines of code that include the core library. And this is all you need to run a Molly application. So for example, if I try to run it, you see that it runs a new application. So for the moment it's empty, but to show you that it's in real time, you can change the background color. So what are the features that I will talk about today? First, the entity component system. Then I will show you how you can draw 3D models on the screen. Then I'll talk about the lighting system and finally the shadows. So one major problem we have in a game engine architecture is that we want to represent objects in the game world. So for example, with a garden scene, you see that I could have a lot of objects in it, and each object has its own data associated, and it has its own behavior, its own way to interact with the world. So this represents a lot of data, and to encapsulate this, we use an entity component system. So basically, you have the scene at the root, and in the scene, you have entities. Each entity has components that you will get from a list of components. So the rendering system, so what we want is to draw things on the screen, and for that we need a graphics API. The one I chose for my project is OpenGL. OpenGL is a cross-platform API for 2D and 3D graphics rendering that provides a set of functions to interact with the GPU. So basically, OpenGL is just the bridge between you, the developer, and your graphic card. And this is how Molly will render a 3D model. So at first, you have your 3D model file inside your Molly application, inside the resources folder. The application will send the model data to the Molly core. The Molly core, using a library called async, will extract this data. And using OpenGL, the Molly core will send this to the GPU. The GPU will do a bunch of calculations, send back a frame buffer, and after that, you will be able to draw your model on the screen. So this is just a little video to show you how it works. So on the left, you have the scene hierarchy in which you have all the entities that exist in your scene. And if I click on an entity, for example, the first cat, it has its own components with its own data associated. So as you can see, I can have two objects with the same models, but not the same position. So lighting is really important in graphics programming because it adds a lot of realism, but it could be really complicated to calculate everything. So in OpenGL, we use approximations of reality to simulate the lighting. And for my project, I use the Phong lighting model, which consists of 3 components. The first component is the ambient lighting. So it's a uniform light that simulates general scene brightness by illuminating all objects equally regardless of their orientation. So in real life, objects are almost never completely dark. You always have a far distance light, for example, the moon at night. So objects are almost never completely dark, and that the ambient lighting simulates that. The next one is the diffuse lighting. So this one models the way light scatters when it hits a rough surface. So basically, if a surface faces the light, it will be brighter than a surface that doesn't face the light. And finally, the specular lighting. This one represents shiny highlights on smooth surfaces depending on the viewing angle. So this is just represent around you all the little shiny things on which the light is reflected. And if you combine the three components, you get this result. So it's kind of realistic. It's not perfect, but what is interesting with the Fung lighting is that it's low in calculation. So it's interesting. And as you can see, you can even change the light color. So now that we have our Fung lighting working, I added the three types of light that you usually use in a game engine. So the first one is a directional light to represent lights that are really far away, for example, the sun. The second one are point lights. They are just lights that have as a position in the scene. And the final one is spotlights. It's just a cone of light. And finally, shadows. So shadows are created when an object blocks light, preventing it from reaching another surface. As you can see on the pictures below, shadows are important because it adds a great deal of realism to a lit scene and a greater sense of depth. And in OpenGL, we use a technique called shadow mapping. So we render the scene from the light's point of view, and everything we see from the light perspective is lit, and everything we can see must be in shadow. So now let's do the sandbox demo. So the sandbox is a project you will get by default if you clone the repo on GitHub. It's a project that will allow you to just test the engine capabilities. So it's a scene in which I already put some objects and some lights. So this is what you get when you launch the Sandbox app. So as you can see, you can move the camera around the scene with your keyboard. In the scene hierarchy, you have all the entities that exist in the scene. So for example, if I click on the cat, I have here all the components associated. And with these components, I can change for example, the cat position or his scale, if you want to make like a big cat. You also have some lights. So for example, you have one directional light that simulates the sun. So you can change, obviously, all the data associated to the light, so the Fung lighting values. Change the light color. And you can see that it simulates shadows, and shadows are calculated in real time. So if you change the directional light position, it will change the shadow's position. And if I can put, for example, the game at night, and you see that there's a bunch of point lights and spotlights that already illuminate the scene. And obviously, for each light, you can change the Fung lighting values. And one final thing that I didn't have time to talk about during the presentation is post-processing. So this one allows you to add cool effects in addition of your engine, of your game. So for example, I can put a kernel effect. I can put a pixelation effect. So I don't know if you see well, but it pixelizes your game, or even a chromatic aberration. So there's other features that I didn't have time to talk about, but that I added in my engine. So feel free to ask if you want. And for the future, I plan to first improve the renderer, then do optimizations, do a scene editor, so a graphical user interface, and finally add the other game engine components, because for the moment you can only render a scene. You cannot really make a full game. Thank you for listening. Do you have any questions? No questions?
Thomas,
Why did you name your project Molly?
Molly, it's because the name of my cats are Moshi and Lichi, and it's the first syllabus, and that explains the cat logo.
Okay, thank you.
Thank you, Thomas, for your presentation. What is the most difficult part of your project?
I think the most difficult part was just all the graphics programming stuff. So how you do lighting, how you do shadows. It's things that involve a lot of calculation. So it's something that you really have to dive into, just maths and stuff, just to render a simple light on the screen. So I think it's the hardest.
Thank you.
Moi, j'ai pas de questions, mais bravo, parce que c'est vraiment impressionnant. Et ton usage des pattern builder en factory, notamment pour la création de ton projet, ça a l'air vraiment bien fait. Pour ça.
Merci.
What did you enjoy the most in your project?
I think I enjoyed the hardest part, the graphics programming, so all everything about light, shadows, and stuff, because it's a lot of techniques that are used in real video games. So I learned a lot about this stuff. So it was really interesting.
Okay, thank you.
Thank you.
On se retrouve dans 13 minutes pour le prochain live en machine learning. On se retrouve pour le 3e groupe sur 4. Donc on a Mathéo et Paul-Henri qui vont nous présenter leur projet de machine learning. Je vous souhaite un bon démo les gars.
Thank you. Hello everyone. Today we are going to present you the project portfolio VisioText. So first, who are we? I'm Mathéo Raymond, student machine learning engineer in Alberton School Lille, C20.
And I'm Paul-Henri Leroux. I'm also in C20 machine learning. So what is VisioText? It's simple. It's a image captioning model. So what it does, it's that you give him an image and it will output the description of that said image. So what you see here is the 2 models we used. So the first one on the left is a CNN called VGG16. It uses 2 principal things. One is convolutional layers, so it slides a kernel of different size to regroup the pixel and to extract features. And the second one, the pooling layer, is used to get a smaller version of the output of a convolutional layer.
On the right, you can see the NLP part. It's a type of RNN. We use the LSTM model. It's a perfect mix between the complexity and the efficiency. So how does it work? You can see 3 cell input gate, the forget gate and the output gate. The cell input gate determines how important is the new word compared to the context. The forgetting gate determines what is it important in the context compared to the new word. And the output gate calculates a vector representing the hidden states. The cell states acts like the memory of the cell. And we will be, for the future, use transformers, but you need too much hardware.
So here you see a code snippet used in pre-processing data. So what it does is that it lists every image in a directory, in our training directory, sorry. It resizes the image and it gives it to a model, the VG16 I just talked before. It extracts every feature of every image and then map to the image name every feature present on the image.
So next, the demo live with the application Streamlight. Okay, you can see here the interface, image caption generator. You can give drag and drop the photo or just load in your browser. So here you can see a dog, and here I can generate a caption. And in the bottom, you have a brown dog is running on the grass. I can try another photo if you want. So the new photo is loading. Okay, and now I generate a new caption. And you can see below, little girl, it's not a girl, it's a boy, but he's playing with a yellow toy. It's not really good, but okay, so next.
So what technology we use? So first off, for the language, obviously Python. And for the framework, we use TensorFlow and its high-level library Keras.
And for the alternative, will be to use a PyTorch with the FastAI library.
So why the choice of TensorFlow instead of PyTorch? Two things: we are already familiar with TensorFlow, and also because we used Colab to code, TensorFlow was already installed on it. As for the environment, as I said, we used Google Colab for the development to get better hardware. We used Google Drive to store either the model and the data, and we pushed it to GitHub to be able to show to everybody.
So here you can see the architecture of the code. At the bottom, with the beginning, the process to the recuperation of the Flickr 30K dataset. Then we processed the data by resizing the image and tokenizing the caption. We load the CNN VGG 16 and give it the feature for make an image characteristic. And we use the LSTM layer. This brings us to the training phase, where we can calculate the evaluation metric with the blue score and the loss calculation. And for the test, the model, we use the generate caption function. And to finish, for the visual rendering, we use the Streamlight application. So for the collaboration, we use the Google Colab. Here we can see the file, we can share a whole file, and here the modification in live. We can just modify it and accept the changement of the other domain.
So here is the Kanban we use to organize ourselves. So instead of working with 4 weeks, we used 5 sprints. It allows us to get 25 days of work and around a week if we needed more time on either sprints.
Here you can see the roadmap during the portfolio. For the first sprint, we go to the documentation, the selection of the library, see how you can matching the models, choose a good environment. The sprint 2, the installation of the data, the cleaning and the process, and starting to build the function. Sprint 3, the beginning of the build the model, the training and the first test. Sprint 5, the changement of the hyperparameter, the improving the model, and another test with debugging. And the last sprint, just the preparation of the documentation, cleaning the code, and that's all.
So the challenges, first of the technical challenges we encountered. First, the feature extraction and the dimension compatibility between our two models. And also we add a lot of overfitting. And for the non-technical, it's the usual time management and also the task repartition.
What we have learned during this project was to combine model VGG with the LSTM, method to making data processable with the model, the importance with the collaboration tools, the planning, and to improve the parameter to a better convergence, and find another method like transformers for the future, maybe.
So what are the next steps? First off, we want to try to upgrade the accuracy of the model. We want to first deploy the AI, and then our final goal would be to create a web tool that will take if you have questions on it, and also maybe improve the user interface.
So thank you to hear we, and if you have a question.
Do you have any questions? Yes?
Thank you for your presentation. For your model, how do you training it, and how many times do you have to do it?
We're training on a Google Colab, and
it's about 6 or maybe 7 days in a row of training.
Yeah.
On the total half once.
It's a lot of time. Yes. Thank you.
Why did you choose this model? And the second question, how did you work together? Did you do pair programming?
What's your first question?
The first question is, why did you choose this model? And the second question is, how did you work on this project? Did each of you had his own GitHub branch, or did you do pair programming together?
So for the model selection, VGG16 simply because it's one of the most accurate yet really simple models. So it's when extracting features, like in the code snippet, it's, I say, fairly short to extract every feature. And for the LSTM, it's because simple RNNs are really not that good at natural language processing, and more complex models like bidirectional LSTM or transformers. Transformers ask for too many data that we didn't have, and bidirectional LSTMs are a bit too complex, so it like you have more training, more time to train, but it's not that rewarding. And what was the second question? How did we work together? Well, you can, just like Google Docs, you can share Google Colabs, so we can both work on it live.
Il y a une question ici.
Did you use Jupyter?
Well, Google Colab is on Jupyter.
Yes.
It's on Jupyter, okay.
Yeah.
Because it will be nice to make a demo, you know, with any progress. And also, you are using pre-trained model, no? Such as MobileNet or something like?
Oh, yeah, VGG16 is pre-trained.
Pre-trained, yeah.
Okay.
The LSTM is trained by us, but the VGG16, yes,
it was imported.
Okay, thanks.
What is the accuracy of your model?
Now it's 57. Yeah.
Wow. And how do you plan to improve it?
Maybe a better large data set and add hyperparameters, new hyperparameters.
Okay, thank you.
No more question? Ok, merci beaucoup. On se retrouve d'ici 15 minutes pour le prochain et dernier live avec Mathieu en spécialisation full stack. Encore bravo.
Merci. Je dirais.
On est de retour pour le dernier live de Mathieu Morel, spécialisation full stack, Olby C20. Je te laisse la parole et je te souhaite un bon démodé.
Thank you. Hi everyone, thank you for being today. I'm excited to present my application EasyTrip. EasyTrip is a travel planning platform. The idea for this application came to me while we were planning our last vacation with our friends. My wife took on the responsibility of organize everything. She spent a lot of time looking for activities, places to visit, and arranging all the details. We quickly realized that it wasn't easy. It's easy to get lost in the process, and it becomes quite time consuming. The team being EasyTrip is it's me. My name is Mathieu Morel. I'm a full stack developer and a member of the Core 20 at Alberton School from Lille. And now let's move on the EasyTrip demonstration. No. Okay. Okay, welcome to EasyTrip. This is my home page with a login button for my connection. When you click on this button, the different options appear. You can log with Google or log the classic method with email and password and register. To save time, I'm logged in Google. Oh, this is my, okay. Okay, you can see the different options appear at the top. You can see the create tip button, history my trips, and button for personal data with information for the user. You can update the data and delete your account. Now let's go to the creation trips. The user needs to enter the destination and the number of days, the budget, and the number of traveler. We can show the demo. Ines, where do you want to go on your next vacancy?
London.
Oh, London. Very good destination. Okay, London. Number of days. 3, 4, 5. Okay. Your budget? Ooh. And? Solo. Okay. Generation, your trip. Okay, and here is your plane trip. You can see all information previously entered, number of days, budget, and number of travelers. You can see the hotel recommendation for your trip. And before, you can see the day with the activity, day per day, and the restaurant and diner. For the first day, this is your planification. Number 2, you continue. Number 3, you can see number 4 and 5. Your trip is ready. We leave when you want from London. Now, by clicking on My Trips, we can view our plane trip and my before trip. And pagination for the next. I can also delete it on the trip is completed, for example. Las Vegas. Delete. Bye-bye. And if I click on the deconnection, I return to the home page. And continue. For the front end, I choose Vite, React, and Tailwind for their speed and flexibility, which enable me to create a dynamic and a responsive interface. For the backend, Node.js and Express were chosen for their simplicity and easy integration to the front end, and JavaScript for the whole project. For the database, I opt for MySQL because it's structured and available. I integrate API such as Google Place to enrich the data of destination and activities, Gemini and GeoName for create itineraries. Finally, to manage the project, I use Trello and GitHub to track progress and organize the work. This is my architecture of application. The user interact with the front-end interface when they perform an action like creating a trip. Request is sent to the backend. The backend processes this request following the MVC pattern, accessing the database to retrieve or update the necessary information. It then calls external services to enrich the trip data. On the data is retrieved and processed, it is sent back to the front end, which display is to the user. Here is an important code snippet for my application. This function handles the trip creation process. It begins by checking that all required fields are filled in, then constructs the final prompt for the AI using the user's input. The AI generates an itinerary, which is then parsed and structured before being sent to the backend. Finally, the trip data is including a hotel recommendation and daily plans are saved and displayed to the user. Here is a development schedule. The week one mainly involves analyzing user requirements, defining functionalities and configuring the environment. The week two starts off backend development and the creation of the first component and the creation of the first pages. the week 3 development of functionalities and other page, and the week 4 debugging and testing my application. I successfully integrate artificial intelligence into the application for the trip planning, and the trip management features are working well. The interface is smooth, and the data integrated correctly into the database, which is very, very satisfying. However, there were some challenges, especially with the database in the beginning and structuring of the AI result, which made sending data to the database complicated. My goal now is to improve the accuracy of AI, optimize the application performance and security. This project has enabled me to acquire a number of skills and continue my learning, particularly in terms of API management, integrating artificial intelligence into web application, and front-end development with React and Taiwan CSS. During discussion, a number of people here have come up with ideas for improving my application. For example, integrating a digital travel journey where user can store all their documents, such as plane tickets, activity booking, and passport information. Another suggestion was to add a chatbot to help users create their own trip according to their wishes and needs. Their improvement will enhance to user experience to my application. To conclude, after 2 years at Holberton and starting from scratch with no development skill, I am proud of what I've learned and accomplished here. I'd like to say a big thank you to everyone who has supported me from the start in C19. Thank you, Arthur, Fabien, Caroline, Laetitia, all people, and especially my wife, Caroline. Who has accompanied me on this adventure. Thank you for valuable advice and support. Thank you, everybody. If you have any question, it's now.
Est-ce que certains d'entre vous ont des questions pour Mathieu ?
Thank you, Mathieu. Was it the first time you worked with AI in a project?
Yes, this is my first time. I chose Gemini for testing, and I have a very good result.
And was it hard?
No, the documentation is good, and is a facility to implement on my application.
Okay, thank you.
You're welcome.
Thank you. I know that Google Place is really expensive, and
yes, it's very expensive. This is a promotion for this project. I have $2,040.
Wow.
Is possible for testing in my application. Before I'm delayed I pay places because it's very expensive.
I know that. And also Gemini is expensive too, or?
It's free.
It's free?
Yes.
Completely free?
Yes.
Okay. Have you tried Selenium WebDriver or something like to overpass Google Place? Selenium or any scraper?
No, no scraper for this project.
Okay.
This is just a API Google Place, and I'm recover the image and the detail for the place, and this is just that.
Okay, thanks. Apologies for the $200.
Houssem, software engineer.
Are you going to commercialize the application?
Maybe I'm finished the small feature. If is it possible to commercialize? Sure, but I find an option, a different option to Google Google API because it's very expensive.
And are you going to truly use it for your next trip?
I try.
Okay.
Yes.
And one last question. Does the app, or maybe later on, will it take into consideration, for example, natural disasters? If I type destination and there's like an earthquake or an attack or terrorist attack or something, or
For the
or
moment,
revolution or anything.
yes. I'm not sure your question. I don't understand all your question.
Je peux le poser en français.
Yes, please.
Est-ce que je sais pas si c'est un cas extrême, si un jour je tape une destination, je suis pas au courant de ce qui se passe là-bas. S'il y a une catastrophe naturelle, une attaque terroriste, un coup d'État ou un truc du genre, est-ce que ça prend pas en considération? Ça me met une alerte. De tel jour à tel jour, il y a un événement où il faut faire gaffe.
No, for the moment, is not implemented. But if the future features and send a message alert for this is a war or cyclone, yes, I don't know. It's a good idea. Thank you. Any question? Yeah.
How do you use the AI in your project?
My project?
Yes.
Yes, I'm using Gemini, API Gemini for add an information and create a trip. I'm send a request to the backend. The backend send the prompt to the API Gemini, and Gemini return the trip. And after I place the trip on my database and the screen for the user.
Thank you.
You're welcome.
And what about the security of your website?
Oh. I have a slide because this is my security. This next to a slide. I have for the project I'm use Bscript for the password and JSON Web token for the authenticate user. I'm use expressword limiter for the number of requests and the cores for authorized to access the API. I forget, and a verify token. And for SQL injection, I'm use a parameter for our pass in a reform, allowing to use of prepare queries. This prevent attacker from injecting SQL code, and as the value is correctly escaped. That's all.
Thank you, Mathieu.
You're welcome.
Merci à tous d'avoir participé à ce live. Merci à ceux qui étaient en ligne. Merci aux entreprises qui étaient ici. On va avoir un petit temps d'échange après avec vous pour que vous puissiez un peu vous présenter ou vous représenter pour ceux qui ne vous connaissent pas. En tout cas, bravo et merci pour la qualité de votre travail, les C20. Je vous souhaite plein de bonnes choses et puis on se dit à bientôt en novembre.